Hello everyone, good evening. I think I'm audible to all of you. Let me know in the chat. Hello everyone. Yeah, hi NJ. Hi guys. I think I'm audible. Let me know if you can hear me, you can see me, guys. Okay, so welcome to day 9 of our Computer Vision for Developer series, and today the topic is backpropagation in convolutional neural network. Okay, so far we have completed so many topics inside CNN. Let me show you guys. So this is the playlist. So if you click on the playlist, so we have completed till day 8, and we have like covered so many topics. And I think in my last session I was talking about the deconstructing CNN vision and the data augmentation. Okay, one very important let's say topics inside CNN. Okay, and this topic will help you to understand, this topic will help you to build your own architecture and how we can improve that architecture as well. Okay, with different methods. So one of the methods I told you, the data augmentation part, and it is super important. Okay, whenever you are training the model. Then I told you guys I'll be also discussing about the backpropagation in CNN, like how backpropagation happens usually. So here I'm not going to deep into the entire, let's say, low level mathematics, guys, because at the end mathematics would be pretty huge. Okay, so here I'm going to give you the high level overview how backpropagation happens in the convolutional neural network. Okay, and how it will try to update the weights, and what are the weights would be updated during the backpropagation. So this should be the concept of the video. So those who are from deep learning background, I think you know, guys, in neural network also we do the same thing. We do the backpropagation and we update the weights, right? Yeah, so to understand this session, guys, you should have knowledge on deep learning. Deep learning actually this back propagation, then you will be able to understand this particular session. Okay, yeah, so deep learning knowledge is required a little bit, because in deep learning you will be understanding the back propagation concept, forward pass and backward pass, this concept, and the weight upgrade concept, right? Yeah, and to understand this one you should have knowledge on calculus, like at least the derivation part. Okay, how derivation happens. Yeah, see here, this is not our main, let's say, intention. This thing I'm showing you because I want to be everyone understand this thing, how back propagation happens in the convolutions, because I know that many people has the confusion. What are the weights actually it updates during the back propagation in CNN, because they know about the NN, but what about the CNN? Okay, so that is what I want to clarify that. But this is not the actual, let's say, topic for the developments. Okay, yeah, if you know it, it's completely fine, because you are entering into the, I mean, mathematics here, right? Hmm. So if you're not getting this session, guys, it's completely fine. Okay. Hmm. Fine, so for this let's open up my blackboard and let me write down the agenda. Just a minute. Yeah, but no need to worry, guys, the way I'm going to explain, I think most of the people will be able to understand. Okay, just try to see, okay, whatever I'm going to do. So let me connect my pen. So the topic is backpropagation. Backpropagation in CNN. Okay, convolutional neural network. Yeah. So I think you have studied artificial neural network, guys. Yes or no? ANN, right? How we create the ANN architecture? Let's say here we take some nodes. Let's say this is our input layer, and we usually take some hidden layer. Okay, so this is, let's say, my hidden layer, and let's say this is my output layer. So here you make the connection. This is the input. Let's say x1, x2, and this is your output y hat. Okay, and here what you have guys at the end, tell me. Here you have some weights, yes or no? Here you have some weights. Let's say weight 1, weight 2, weight 3, weight 4, weight 5, weight 6, and weight 7. And with that you will also have some bias. Let's say b1 plus b2 plus b3. Okay, so these are my weights. Okay, so if I show you inside artificial neural network, so here how many weights you are having. So if I just write w, okay, w is equal to, I have here w1, then I have w2, w3, w4, then w5, w6, w7. Okay, w7. Yeah, so w7 weights you are having, and how many biases you are having. B is equal to, so you are having b1, b2, and this is the last layer, right? And you are having b3. Got it? Hmm. So how many of you are familiar with guys this concept like artificial neural network? Tell me. So output layer you don't need to take. Let me remove it because this is the output layer. Okay. Hmm. So here I can remove this one and this one. Fine. So that's how actually we do the like weight update operation. So these are the weight would be updated inside artificial neural network. But what about CNN? What about convolutional neural network? So let's try to understand. Okay, let's try to understand the convolutional neural network. How we usually draw the network. So I think you remember, guys. Let's say this is our image. So here we are doing it for the CNN. CNN, okay, convolutional neural network. So let's say this is my image. This is my image. Let's say the image size is 6 cross 6. Okay, 6 cross 6. Okay, and here you have, let's say, one person or anything you are having in the image. So what you do, let me draw it. You apply something called filters. Yes or no? You apply filters. Let's say filter size is 3 cross 3. Okay, you apply some filters and it will give you what? It will give you feature map. This will give you feature map, FM. Okay, let's consider this is our feature map. Then what you apply, guys? You apply ReLU activation function. You apply ReLU activation function. ReLU. Now, if I do the if I apply the filters, 3 filters on 6 cross 6 image, so the feature map I will be getting, guys, 4 cross 4. Okay, 4 cross 4. Okay, it will be 4 cross 4. And if I pass it to the ReLU, again I will be having 4 cross 4 because ReLU will only do the uh, like this one. If it is a, let's say, minus, it will bring it to the uh, let's say 0, and if it is, let's say, any number, it will bring it to the, I mean, that number. This is the idea. Then here what I will get, guys, I will pass it to the max pooling. So here I can write, this is our max pooling. Max pool. Okay, max pool. So after applying max pool, guys, what will happen? This image will be reduced by half. So you'll be getting 2 cross 2 image. Okay, 2 cross 2, let's say. feature map. Then what you will do, tell me, you will try to pass to the flatten layer. So let's say this is your flatten layer. Let's say this is your flatten layer. Flatten layer, okay? Yeah. Now what will happen here? You have some, let's say, neuron. Let's say 1, 2, 3, and 4. And you'll just pass it like that. And this is your fully connected neural network, okay? And here you'll be getting the y hat. Okay, y hat. So this is your output. Yes or no? That means this part is your CNN. This part is your CNN. And this part is your ANN. That means in convolution, what will happen? In CNN and ANN, in both places, your convolution, backpropagation will be happening. Okay, both places, your backpropagation will be happening. Now, first of all, let's try to figure out the weights. Okay, like what are the weights we are having in this particular architecture? Now, see the first weight. You can see whenever you applied these filters. Okay, this filter is nothing but the weight. So let's say I will consider as a W1. So here let's say I'm applying only one filters. So that's why I'm only having one weight W1. And this weight is nothing but it's a matrix, 3x3 matrix. Because inside filters we have, what we have guys? We have some number, right? We have some filters number, and that filter numbers, what happens? It will try to extract the features, right? And these filters, okay, because initially what happens whenever we create the architecture, this number would be defined randomly. And what we have to do, we have to do the training operation, and during the back propagation this weight would be updated. That means this number would be updated. So as of now, let's consider this is we are using only one filters, and this is our weight, okay, called W1, and it's a matrix, 3x3 matrix. Okay, and obviously you will be also adding a bias, because I told you in my last session, whenever we show the deconstruction of the CNN, we also apply something called bias. So let's say we are adding a bias here, plus B1. Okay, B1. Let's say this is our bias. And this weight is nothing but it's a 3x3 matrix. Okay, it's a 3x3 matrix. And this bias is nothing but it's a scalar number. It's a scalar number. So you can write 1x1 or just 1. Okay, it's a scalar number only at the end. Okay, now this is the feature map. So this is not the weight. This is the ReLU. This is not the weight, because at the end this is the activation function only. Yes or no, right? Then max pooling, again this is not the weight. Okay, it won't be updated. Now again another weight you will be getting in the artificial neural network. Okay, so here you will be getting some weights. Okay, you will be getting some weights. So let's say this weight I can consider as a W2. Okay, I can consider as a W2. And how many weights you are having guys here? So you can see you are having four actually unit. So 1, 2. So you can see guys, 1, 2, 3, 4. So here you will be getting I can just write like, let's say this is my W. So here you'll be getting four weights, 1, 2, 3, and 4. Okay, that means this matrix size would be, what would be the matrix size? It would be 1 x 4. Okay, 1 x 4 matrix. That means it's a vector. Okay, then it's a vector you can consider. And again it will have the bias. So I can add, let's say, plus B2. This is my bias. Again it would be a scalar number. Okay, it would be a scalar number, let's say 1. So I think you got it guys, how to identify the weights. Yes or no? How to identify the weights from these kinds of architecture. Let's say you are using three filters. That times you'll be having 3 weight, W1, W2, and W3, and all of the weights will have the size of 3x3. Okay, if you are using 3x3 filters, and at the end this is just a matrix. Okay, and again these are the layer, you are not doing anything. Okay, you are not, let's upgrading the weights, because this is not the weights. And again if you go to the artificial neural network, okay, so here we'll be getting the weights. Okay, the same thing we learned here. Okay, got it? Now let's try to identify the trainable parameter. Okay, we'll try to identify the trainable parameter here in this architecture. So let me just write here trainable all parameter. So here trainable parameter you have the W1, okay, because this is the filters you are using, and then this is a weight. Okay, so W1 is equal to, so it's a 3 cross 3 matrix. So I can also write it like that, 3 matrix. Okay, 3 matrix. Then you have W2. Okay, you can see you have W2, and W2, what is the like size of the weights? It's you can consider W2 is equal to 1 comma 4. Okay, 1 comma 4 matrix. Then you have the bias B1. So B1, what is the size? The size of B1 is 1 cross 1. Okay, it's a scalar number, and you have having B2. Okay, B2 you can also consider it's a 1 cross 1 because it's a scalar number at the end. So these are the trainable parameter, guys, I'm having. Now how many trainable parameter, guys, in total? Okay, in total how many parameter you have here? Tell me. Total how many parameter? Total. Just try to count. You can count, guys. How many parameter? So you can count. So here you are having 9, 10, 11, 12, 13, 14, and 15. Okay, if you combine all of them, you will be getting 15 trainable parameter. 15 parameter. I can write trainable parameter. Trainable parameter. Okay, in this architecture, I'm getting 15 trainable parameter. Now, if you're using any big architecture, if you're using, let's say, more these filters and more the, let's say, this FC layer, so that time your trainable parameter will be increasing. So you can also take a pen and paper and you can also do the experiment. Okay, you can also do the experiment on your pen and paper. How? Just try to see. You can multiply 3 cross 3. It will give you 9, right? 9. That means 9 value. And again here you are having only one value. That means 10. And you are having 4 value. Okay, you are having 4 value. That means 14, and you are having 1 value. That means 15. Total 15 parameter. Yeah, weights and biases. Okay, because weights and biases both are parameter, both are trainable parameter, both would be updated during the back propagation. Okay, it's not like that only weight would be updated. Also bias should be also updated. Weight and biases both, right? So that's why I told you guys little bit ANN knowledge is required. Okay, at the end, because in ANN I think this topic should be clear. Okay. Yeah. And at the end, guys, what happens? Let's see here we're doing the binary classification. Okay, this is the prediction. So here, based on the prediction, you also calculate the loss, yes or no. You calculate the loss. Okay, and this is a binary classification problem statement. So let's assume we are using binary cross entropy loss. And what is the equation of binary cross entropy loss? It should be L is equal to minus y1. Okay, log. Let me write it. Y1. Oh, sorry, yi, then log y hat I minus 1 y1, then log of my 1 minus y I. Yeah, so this is the value. So sorry, this is the equation. Okay, this is the binary cross entropy equation. This is the loss function you can talk about. You can also use different loss function. It's up to you. There are different loss function are available. Okay, categorical cross entropy, binary cross entropy. So these are the laws are available. Hmm. Okay. And now, first of all, let's try to understand one logic diagram. Okay, how things will work. So here I'm going to show you one logic diagram. Logic, logic, logical flow or diagram. See, first of all, you are giving a input. Let's say input is x. Okay, input is x. And what you are doing, you are applying something called convolution. Let's say this is the multiplication symbol. You can consider this is what? This is your convolution. And in the convolution, you use one matrix. So you use W1 and B1. That means weights and biases. Okay, both here. And the output you are getting, let's consider this is the Z1 output. You are getting a Z1 output. Okay, after doing the convolution operations. Then this Z1 output, what you are applying? You are applying ReLU. Okay, what you are applying? You are applying ReLU activation function. And the output you are getting, let's consider this is A1. Okay, activation function. That's why you are considering as A1. Okay, then this ReLU output we are passing to the max pooling layer, guys. Okay, why? We are passing to the max pooling. Okay, max pool. And the output we are getting after max pooling, let's say this is P1. Okay, P1. Then again, this max pooling output we are sending where? To the fully connected, flatten layer. Okay, and the flatten output we are getting. Okay, the flatten output. See, after flattening, what we are doing? After flattening, you are doing some operation here. Okay, you are doing some operation. That means FC operation, and the output you are getting. That means here. So let's consider this output. It would be Z, let's say 2. Okay, then after so here we are getting the output. This is called Z2. Now after that, you are sending to where? To the last layer, and last layer you are using sigmoid activation function. I think you know that this is a binary classification. That's why you are using sigmoid activation function. So what will happen? Let's say you are applying sigmoid here. Sigmoid. Okay, sigmoid activation function, and the output you are getting, let's say I can consider it's a A2. Okay, and based on the output, let's say this is your y hat. Okay, this is your y hat. That means A2 is equal to your y hat at the end. Okay, and based on this y hat, that means A2, you calculate the loss. Okay, calculate the loss. So let's say this is the entire logical flow. Now based on that, we'll try yeah, now we'll try to understand, we'll try to break this thing, and we'll try to understand, okay, how this weight upgrade will happen in the CNN architecture. Okay, hmm, yeah, now see, let's try to understand how this how this parameter is coming. So here what I will do, I'll take a new color. Yeah, so first of all, let's try to see how this Z is coming. Z1. Okay, how this Z1 is coming, guys? Tell me. Z1 is coming, you are doing the convolution operation. Okay, so this is called convolution operation, conv operation. So here, let's say we are performing the convolution operation, conv. Okay, and in convolution, what happens? You use filters, and filter is nothing but your weight. So W1. Okay, first of all, you have the input image X. Okay, then you are using W1. Okay, then what you are using, guys? Let's see, you are multiplying it. Then you are adding the bias here, B1. Got it? So this is nothing but your Z1. Okay, now let's try to understand how this A1 is coming. So A1, how A1 is coming? This A1 is coming, you are applying the ReLU on top of the Z1. That means I'm applying ReLU on top of the Z1. Z1. Okay, so this is nothing but my A1. All right, now how this P1 is coming? Okay, how this P1 is coming? That means here you can see you are applying max pooling on top of A1. So that means here I can write P1 is coming. We are applying max pool. Okay, we are applying max pool on top of A1. That's why we are getting the P1. Okay, now how this F is coming? Okay, F is nothing but your flatten layer. Okay, so that means you are doing the flatten operation of P1. So here I can write uh, F is equal to, it is the flatten, okay, flatten operation of P1. Okay, so this is my F. Now how this Z2 is coming? Okay, how this Z2 is coming, guys? So here again what you are doing, so you have the weight now in Z2. In Z2 you have the weight called W2. Okay, you are multiplying W2 with F, that means flatten. Okay, then you are adding the bias, that means B2. So here I can write like that. So Z2 is equal to, it should be W2 multiplied by F plus B2. Okay, then how you are getting this A2? A2 you are getting, you are applying the sigmoid on top of Z2. So here I can write A2 is equal to sigmoid, okay, on top of the, so let me just draw the sigmoid. Okay, so it's reshaping that, so I can draw sigmoid on top of this Z2, okay. So this is nothing but my A2. So that's how, guys, we are getting all the parameter. See, all the parameter we are getting. Now I think you understood, okay, how this parameter is getting calculated. Yes or no? Tell me. Okay. Hmm. 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 Now how forward pass will happen? Forward pass. Forward pass. Pass or propagation. So first of all, you have to define all the weights. Okay. So here, how many weights you are having? You are having W1. You can see here you are having W1 and W2. Okay, W1 and W2 and B1 and B2. So these are the weights you are having. So let's try to write it. So we write it with the help of gradient descent. I think, remember, guys, you know the gradient descent, na? Gradient descent. So with the help of gradient descent, we try to reach to the global minima. Descent. Okay, gradient descent. So how to write the gradient descent? So let's say this is my W1. Okay, so W1 is equal to W1 minus learning rate. Okay, so derivative of loss with respect to derivative of W1. So this is what your W1. So that's how this W1 would be updated. This W1 parameter would be updated. You can see this W1 weight would be updated. Okay, now what about W2? W2. W2 I can write like that, W2 minus learning rate, okay, then derivative of loss with respect to derivative of W2. So that's how this W2 would be updated. So this is W2, guys. So let me write it. So this is my W2. Okay, W2. Now what about biases? So B1 is equal to B1 minus learning rate derivative of loss with respect to derivative of B1. Okay, so that's how this B1 would be updated. Okay, now what about B2? So B2 is equal to B2 minus learning rate. You have derivative of loss with respect to B2. Okay, so that's how B2 would be updated. So that's how all the equation came, guys. Okay, why we use ReLU? Because see, researcher did different experiment with different activation function, and this all like ReLU was working fine. Okay, in CNN, that's why ReLU. Okay, yeah, because ReLU will take the non-linear okay value. Hmm. All right. Now let's try to understand the back propagation. Okay, backward pass. Backward pass. I can take a new color. Backward pass. So I think you know that, guys. In backward pass we use something called chain rule. So do you remember the chain rule, guys? Chain rule, how chain rule works? Yeah. So to make you understand the chain rule, guys, what I will do, I will again draw that same logical flow. So let's copy that. Copy. I will paste it here. Okay, so this is my same logical flow. Okay. Yep. So let's say first of all we'll try to understand the backward pass of the W1. Okay, that means this way. That means here, this one we are talking about. And see, if you update anything here, let's say if I update anything here, mm, hmm, so if I update anything here, that means in this particular weight, so this update will reflect Z1 also, right? If Z1 is getting updated, it will also reflect in A1 also. If A1 is getting updated, that means it will also reflect in P1 also. Then P1 is also getting updated, it will also reflect F, okay, then Z2, then A2, and so on. That means if you change anything here, okay, if any update is happening here, that means it will reflect to all of the parameter, okay, all of the parameter, that means Z1, A1, P1, and so on. So that means there is a connection. Okay, and now with respect to that we have to write the chain rule. Okay, how we write the chain rule, let's try to understand. So here what I will do, yeah, so first of all let's try to write for the w1 and b1. Okay, so this w1 and b1. So see here I can write, I can take a new color. Yeah, I can write derivative of loss with respect to w1, okay, is equal to, see, if any changes happen in the w1, it will be connected with derivative of loss with respect to a2. Okay, a2, that means from here it will be changing. Okay, because it is the chain rule, so we have to update from the right side. Okay, we have to update from the right side, right to left. Okay, so that means we are starting from here. So if any change is happening in the w1, that means my a1 will also change, yes or no, sorry, a2 will also change, okay, with respect to the loss. Then I can write multiply derivative of a2, okay, derivative of a2 with respect to derivative of z2, because you can see z2 would be also updated. Okay, if a2 is getting changed, okay, that means j2 is also getting changed here, z2. Okay, z2, I can write it like that, z2, z2. Okay, then I can again do the multiply, then derivative of z2 divided by, okay, what you have here. Okay, just try to see, you have derivative of f, that means this f value will also change. Now again multiply derivative of f divided by, okay, derivative of p1, then multiply, then derivative of p1 divided by derivative of a1. Okay, a1, then again derivative of a1, sorry, here I can write derivative of a1. So derivative of a1 divided by you have derivative of z2, z1, sorry, z1. Okay, then finally you have uh, derivative of z1 divided by uh, derivative of w1. Sorry, I think I lost that here, so it would be w1, it would be w1. Okay. So this is the entire chain rule, guys. Okay. So based on this particular formula, this weight would be updated. Okay, during back propagation. Got it? Hmm. Now what about for the B1? Okay, let's try to also do it for the B1. So here I will just write derivative of loss with B1 is equal to. So again, you can start from here. Okay, you can start from here. So I can write if let's say if any change is there in the B1, okay, that means these are the parameter will also change. So I'll just write derivative of loss with respect to derivative of A2. So here I'm having the A2. Now multiply derivative of A2 divided by, after A2 what you have Z2, derivative of Z2. Okay, Z2, Z2. Okay, then multiply derivative of Z2 divided by you have F, derivative of F. Okay, then multiply derivative of F divided by you have P1, so derivative of P1, then multiply derivative of P1 divided by, you are having A1, sorry, it should be A1. Okay, then multiply A1 divided by, you have Z1. Okay, Z1, derivative of Z1. Okay, then multiply derivative of Z1 divided by, you have derivative of B1, so derivative of B1. Okay, so this is the entire formula. So this will update the W1 weights, okay, based on the loss, and this will update the B1 weights based on the loss. Okay, this is the entire chain rule. Clear? Tell me. So that's how, guys, entire weight updation will be happening. Okay, the same concept you have learned inside artificial neural network. Okay, so same concept, only the thing is there, it will be changing this weight, your filter weight. Okay, filter numbers, that means this W1, and at then all the calculation you are doing, it's a matrix calculation you are doing. This is the difference. Okay, and here two places you are doing the weight update, so one weight update you are doing in the W1, that means in the CNN. Okay, and another weight update you will be doing in the ANN. Now let's try to also do it for the W2. That means we have done here, we have done till W1. Now let's try to see for the W2 also. So here what I will do, let me show you the W2 also here. So for W2, guys, I can write like that. So I take a new color. So derivative of L with respect to W2. Okay, W2 now equal to, now if you see the diagram, let's say if W1 is getting changed. Okay, if W1 is getting changed, that means sorry, if W2 is getting changed, that means it will reflect where, guys? Tell me. It will reflect where? So here you have, after flatten, okay, you have A2 and Z2. Okay, A2 and Z2. Okay, so I can write like that. So derivative of L, it would be derivative of A2. Okay, A2, because here you can see A2 we are having. Okay, then next reflect will be happening in the Z2. So I'll just write multiply derivative of A2 divided by derivative of Z2. Okay, then multiply derivative of Z2 divided by derivative of W2. Okay, now I think you can understand, because here is the W2 till flatten layer. Here you have the W2. Here you have the W2. Okay, so that's why this is the formula for the W2. Okay, now what about for the bias? Okay, you also have the bias here, because W2 is having also B2. You can see B2. So now let's try to also calculate for the B2. So here I can write derivative of L with respect to B2 is equal to derivative of L with respect to B, sorry, it should not be B, it should be A2. Okay, A2. So here you can see, guys, you're having the A2. Now multiply derivative of A2, it would be derivative of Z2. Z2. Okay, then multiply derivative of Z2, it would be derivative of B2. Okay, so this is the formula for the biases. Now this weight would be updated, and this weight should be also updated based on the loss during back propagations. Okay, and that's how, okay, it would be doing multiple time. Okay, it would be multiple time until this loss is, okay, loss is close to zero. Loss is close to zero. Okay, so here this loss, the loss we have written, this L is equal to, this loss would be close to zero. So this is the entire idea, guys. Okay, that's how convolution happens inside CNN architecture. So only the difference is in ANN, okay, in ANN you try to calculate for all the weights, okay, but in CNN you calculate the weights for the filters as well. Okay, this is the filters, and filter is nothing but it's a weights and it's a matrix. Now if you're using multiple filters, guys, so in multiple filters the same calculation would be happening. Now you can also take a pen and paper, and you can also do these kinds of experiment. Here I've showed you with the help of single filter. Now you can also consider multiple filters. So that's why I told you. So in-depth mathematics I'm not going to teach you because it will take lots of time, and there are like so many equation you have to write at the end. So I have given you the high level overview. Okay, that's how things are working. Now you can consider, okay, for the other remaining, let's say, weights or other remaining filters, okay, how it will calculate the entire parameter and how it will update the weights. So did you get some basics high level idea, guys? Tell me. At least the basics idea, like how this weight updation is happening in the CNN and why it is happening. So this is a very good interview question. So they may ask you in CNN architecture why this weight upgradation happens. Okay, why this weight upgradation happens, why this kinds of back propagation happens. Now I think you have the knowledge. Okay, it will be happening in the filters layer. Okay, filter layer, and it will be happening in the FC layer. Yeah, interview will ask that. I've seen some interview will ask this kinds of question. In CNN architecture, where convolution, where back propagation happens, where weight updation happens. So many people will get confused and they will tell like in the ReLU, in the, let's say, max pooling, so every layer back propagation happens, but it's not like that. Back propagation will only happen in the filters. Okay, filters matrix, not any other layer, and it will be happening in the FC layer. Okay, and how? That's how. With the help of chain rule, and all the calculation are happening matrix calculation here. This is the difference only. Got it? At least the high level overview, guys, how things are working. Tell me. Again, you can pause the video, guys. You can rewatch that same video. Your understanding would be clear. I know that, because in live session sometimes you may miss some of the point. Okay, so I'll suggest you guys after so after this class, just try to again watch the recording. If he asks why, then okay, see, why means you know the why, na, you know the why, like why this weight updation happens. If I'm not doing the weight updation, okay, if there is no weight update, if there is no filter change, so it won't be able to extract the relevant information, because I'll have like very high loss now at the end. To reduce the loss, I have to do this kinds of back propagation. So I think you know that, right? No, how they will not ask you. See, mathematical terms they will not ask you. They may give you this kinds of scenario based question, like in CNN architecture, which layer actually, let's say, update during the back propagation. That time you can tell like in the filters, okay, filters layer, it will do the back propagation. That means in the convolutional layer, it will do the back propagations, okay, and in the FC layer, it will do the back propagations. That's how you have to answer. They will not tell you like try to write the mathematics and all. They will not tell you that part. Okay, unless and until you are not going for any research position that time. Because if you're doing research, guys, that time mathematics is super important. Okay, you have to know the in-depth mathematics, how things are working, how all the equation is getting, let's say, build up. Okay, how things are getting calculated, each and everything you have to explore. But here we are not going into the research field. Okay, so here we are more focusing on the development field. So at the end we have to understand this at the part as a high level. At least we can understand, okay, so that's how CNN is working in the backend. Got it? Because at the end you are not going to use the mathematics in your development. I hope it makes sense now, right? Yeah, so the training finds the best filters to apply on the image to extract the correct features. Okay, this is the idea. And how this filter will get updated with this formula. This formula, okay? And this is called backpropagation concept as a high level. Got it? Yeah. Now that's why I told you guys, for this you need some understanding on the artificial neural network, ANN, that means deep learning. If you're completely new to this deep learning, so know that it would be a little bit difficult for you to understand this mathematics. Okay, because for this you also should know the differential calculus. Okay, so this is the differential calculus. So maybe you should have some idea. No worry, maybe in future I will also come up with deep learning playlist on my channel. Okay, we'll also learn the deep learning in depth. Fine. Yeah, so no need to worry, guys. This is not, I mean very important. At the end you just need to get some idea, basics level idea, how things are working in the backend. And now going forward, guys, in the next session onward we'll be starting our uh, very interesting concept called transfer learning. Transfer learning. Okay, that means we'll be working with the pre-trained model. Pre-trained model. Okay, and here we'll be building the application. Okay, we'll building the applications. So next class onward, guys, I'm starting the transfer learning. Okay, transfer learning in CNN, and we'll be working with the pre-trained model. So far we created the model from scratch. So far we use the custom model. Now we'll be using the pre-trained model, and everyone use the pre-trained model, okay, to create the production level architecture, a production level application. Calculus is the best things invented. All new tech and everything is just based on the calculus, definitely. Okay, because all these kinds of automatic backpropagation, loss optimizations, okay, everything is happening with the help of this calculus and this chain rule concept. Okay, so that's why deep learning got evolved, and because of that actually today we are having the large language model and all, okay, everything. Because neural network, how it thinks, because of the backpropagation, automatically it will update the weights based on the loss, like the human does. Okay, let's say if you do one mistakes, so definitely based on your previous experience you will not do the same mistakes. Okay, so the same concept they have mimicked, okay, in the mathematics. And this backpropagation invented by one of the researcher, his name is I think Jeffrey Hinton. So Jeffrey Hinton, so he proposed the backpropagation concept, okay, the first time. Godfather of AI, okay. All right, so any question, guys? If you have any question, let me know. Otherwise, I think we can end the session for today. And next class, guys, we are starting with the transfer learning and pre-trained model. Any question? Okay, I think no questions so far. And please try to rewatch the same video if you are having still some doubt. And you can take the pen and paper and you can draw. Okay, at least you can just do some, let's say, experiment on the pen and paper. Your understanding would be clear. All right. And if you are new to my channel, guys, please try to subscribe. And if you haven't liked the video, please try to like, because your support is required, guys, to grow my channel. Please try to support my channel. And whatever things you need from my side, please let me know. Definitely, I'll try to bring the content over my YouTube channel. Okay. Yeah. No, YOLO is not dying. YOLO, they are having latest version nowadays, like YOLO V10, 11. Okay. Deep sort is for the tracking. YOLO is for like the detection. Okay. Hmm. YOLO is for detection. Now, the latest YOLO, you can also do the segmentation. You can also do the classification. Everything you can do with a single model. And deep sort, it is the tracking algorithm. Yeah, so please subscribe to my channel, guys. Let's try to hit 50k subscriber as soon as possible. And with that, best of luck. So let's meet at the next class, guys, with a new topic. Till then, guys, thank you so much. Good night. Bye, everyone.